Okay, I think we can begin. This one is just going to take a couple of few minutes. It's not going to be long. We've done some visualization before. I'll be doing just a quick recap on just using Jupyter just to visualize your data, because that's what the main concept of yesterday's session. So yeah, it won't be taking long. So yeah, checking on the chats on Slack if everyone has joined. Okay. Seems we can go ahead. Okay, you can just write on the chat if I'm audible, guys. You can just react on that message there. Check if I have anything to fix on my side. Kudos, here we go. Here we go. So far, so good. Okay, I don't know what's that popping up there. Okay, I've seen a lot of like thumbs up. Tells me maybe you can just check on your site, fees as well. Other institutions have reflected with the thumbs up. I haven't seen thumbs down, so okay, 22, 23. Okay, I think we can proceed. Okay. So yeah, yesterday's session was more like using Jupyter Lab to basically visualize your data. Just completing or finishing off what we have already started with visualizing information and visualizing data. We started using Streamlit on day before yesterday. Yesterday, then it was just a quick recap on how you can use Jupyter as well to visualize your data. So I'm quite unsure if I haven't received any students saying they can't open Jupyter, but yeah, you can open Jupyter on your Anaconda. If you have Anaconda, Jupyter Lab, you have Jupyter Lab here, you can just launch that. Once that is launched, you can just open but first you have to just download the files on Canvas, the HAR files that we are using, which is the solution and the template as well. It's there so that we can start. So Benjamin already has gone through this yesterday. So I won't be long. So yeah. So basically what we were doing yesterday, just visualizing the data from the bugs and all that. So we have just have to, not sure why I'm getting that pop-up all the time. Okay, there's quite a couple of changes on there. Okay, so okay, we're gonna start there. Your imports as well. This was sent on I believe that everyone. Okay, I'm just gonna zoom in now. Let's close that as well. I think now it's a bit better. Okay. Okay, yeah, there we go. Hmm. Okay, yeah, here we go. So yeah, the information that we are going to use is in the bike data cs.csv file. It's probably on Canvas as well. You can download that and use it. I've downloaded the file and here is it on my directory. Then I'll be able to use the data that is on that CSV for my analysis, basically, for your analysis per se. So yeah, so what you do is basically you just import it. You import your pandas, datetime. I'm gonna use datetime as well, and time delta. You import your Plotly Express so that you can plot your data and visualize it. So yeah, that's importing your CSV with renamed columns. We'll check on the chats if anyone has questions on that. I'll just go through the code as well as the results, the visualization. So you clean up some data. I'll just have to just clean up the data using that, because this is one of the reasons, because you're gonna use this date column basically for your visualization, just to check as well, and use that for basically your time studies or time related information. So gonna use date time. So just have to make sure that that column is in right format. So that's where you're gonna use now. Okay. So now that's where you're gonna use now the datetime module. Just PD to datetime, and just that is your date column that you want to convert, and make sure that the format is in right format that you can use. So just convert the format and make it look like that. Let me see if we can visualize before that. See if we can do that. Okay, so you can see this is how our data is formatted at the moment. So, but now we want to combine it with an hour as well, so that you can have a datetime that you can use. So yeah, you do that. That's how you convert it and format it basically to the data type that you need or you want to use. Because at the moment it's currently a string, it will result, if you don't do that, basically, if you don't do that, it's going to be right as a string, basically. So you just need to make sure that it's in the right format. Then next line here, basically what you do now, you're concatenating basically date and hour so that you can have a datetime column. So this here will be your datetime, which is a new column that you'll be adding, which consists of the date as well as the hour that you're gonna use for your analysis, basically. And you can check if we. So at this moment we don't have. We currently don't have that. Just do this. Zoom in. Okay. We don't have, okay, we do have, I think we've defined it after as well. So I'm just comment this one off. Let's run. See what happens. Daytime, okay. Do that. CTF, run it. Okay, here you go. So now you have a new column, which is daytime. I'm sure it's not at the end, which has a new format now, and adding also the hours as well. So these are the hours and this is the date. So you're concatenating the two to make that datetime column that you can use. Then that's your step there. That's what's happening here with the plus sign to say you're concatenating the two. If that was on a string, it was going to result in some error of some kind. Then just going to move the next. I'm not sure why I'm getting that, but yeah, there's too much running on my PC as well. Moving forward now. Okay. Moving to the next line, which is holiday. So now what we currently have is a yes and no, or no holiday, basically. We have no holiday for the is holiday column. So we have the inputs of no holiday as well as holiday. So how can we use that information now to visualize? Basically, we can't basically use that. It's going to result in something different, or it's going to be a long step now where you have to check and do some condition to check whether it's yes, whether it's no. So now in Python, the simplest way on how you can do that. So what you can do is you can replace the no holiday to false and holiday to true. And make sure that is type as well as type is Boolean, basically, which is leads to the condition of true and false. Okay. So you make sure that exists. So that will make sure that your results are in true or false after conversion, of course, after replacing that. Okay, let's see. Looks like we have a question on. Okay. Okay, yeah, that's basically what you do here. You're setting no holiday, you're replacing the no holiday basically on this column here. Now I can't move to that side. I have to go to the end of this thing. Okay. So initially here, this column is a yes or no. Now we need it to be false and true, whether if it's holiday is holiday. This is the column that we're dealing with. And of course, we'll be dealing with is functioning as well. Okay. So is holiday, we change if it's holiday to false and to if it's holiday in true. Okay, go back to the code as well as is functioning as well. So you replace is functioning yes or true, meaning that and you set the data type as well. Make sure that it's in Boolean. Okay. So this will be your result after that, because I think the initial result that you get from the CSV, once you download it, you will get a yes or no from that is functioning column, as well as the is holiday column will result to no holiday or holiday. So once you go through the steps, you will get that those results, which is false as well as true for is functioning. Then you will have your datetime as well. Now you're making sure that whatever information that you're going to use for analysis is correct and you're able to basically use it. Right. So we move. So basically that's what those two lines are currently doing there. Basically replacing the no holiday and replacing is holiday and replacing is functioning values. Okay, now what we need to do, we need to keep only the observations where the system is functioning, basically. We don't need to visualize whatever when the system was currently not functioning. We don't need that kind of information to visualize with. There's nothing we can do with that information at this moment. So the information that we need is basically when the system was running. So in a case where, let's say, you need results when the system or was not functioning, what would you do now? For example, in this line here, you can check this line. Uh, so back in, you can check this line. If in Python, for example, if you wanted to check, because now you've already set this, sorry guys about that. You've already checked, you already changed you've replaced basically the values from the is functioning column to true and false. And you made sure that it's Boolean, right? So now you can test whether it's true or false, basically. So once you have that is functioning, results from this query here will result to true in most cases. But if you say you want it to be false, you want to only visualize and print out that, you see. So if we check, let's kindly check our data, what it's showing at the moment. Let's check. So yeah, you can see its function is currently set, showing all the true value, which is yes, the system was functioning at the time of this analysis or what we want to do. So if let's say, example, we change here and say not is functioning, which is now we want the result, the query to result to return false, basically. So we're gonna check again. So now if you need statistics to see if maybe there were people requesting or whatever the case may be when the system was not functioning, you can see now it's resigning to false only by changing that statement. But we don't need that. Okay. So again, these are the results that you will get. So those will be your final result after making sure that this is exactly what your data frame you want it to look like before visualization. Okay. Okay, do this. Okay, remove. Okay. Now again, you want ish. Again, you want now to visualize bike rentals over time. Now, exactly now, this is where now we're gonna use that data column that we've included on our table at the top, on our data frame actually at the top. So we need the daytime as well as the rented bikes as y-axis. This is the data that we want. So basically now this is how you create your line plot using the data frame. On the x-axis, you want the daytime, and on the y-axis, you need the rented bikes, basically. So that's the information you want to check at this current moment. So that's how you're going to visualize it. That's how you're going to show it by only that statement. Then once you run it, you always press the run icon there at the top, run the cell. Then it's going to visualize all the information you want like that. Then you can see the trends, you can see all what you want to see on that line chart there, on the line. That's the information that you will see. You can be able to do analysis and all that you want to do there. You can see actually with the daytime as well, if there's any information that you want to extract there. So again, going down now, what else do you want to see now? Say you want to calculate the total number of rented bikes per day. Let's see if you can, so you can, okay, this is my, okay, just give me a second. I'll check on the chats if there are questions based on that, if maybe is that clear for everyone what was happening on the cleaning of this information, of this data. Okay, I'm checking now on the chats. Okay, everyone looks good. It's good. Okay, we can run this. So yeah, again, now you say you calculate the total number of rented bikes per day. Now you see, now you need to check the date as well as the rented bikes as well. You need to create basically calculate the total number of rented bikes per day. Basically, that's what you're gonna do. This is our solution. So we'll be taking the data frame and group them by date, and then you sum that rented bikes, then select date and rented bikes as well. So that will be your sum, your rented bikes on that day. Then that's how you're gonna visualize your data. Then you go down. Okay, so now here you need to check by seasons now on the day as well. Just copy the information from above and just paste it there. You can just visualize that on the plot as well. You can see there's your information. So basically the main point of yesterday's session was to show you guys of how basically you can use Jupyter to visualize the data, The data that we're currently using for these sessions and for these trainings will be, of course, different from what you will want to visualize. But the main point of this session is to show you that there is an alternative on Streamlit. There is an alternative that you can use from Excel just to visualize your data, of course, you see. So the conditions, now you know Python, you know that you can use Python, you can know that you can clean your data, So you can just use that information that you already know. You can explore the relations between the weather and rentals, all that Benjamin already went through yesterday. I ain't gonna go through that. So yeah, I'll check on the question because there's so much to do as well for today. So we'll check on the questions if maybe there are questions, and we'll reply to that and go to the quiz as well. I'm not sure if that was clear enough, but yeah. Okay, may we please get the flow diagram from the bioinformatics presentation. Thanks in advance. Okay, Belinda. Let me check. Normally we'll upload it. Okay, there we go. Okay. So we're just gonna do the quick review of the quiz. Then that's about it. We'll continue with our bash for today. Okay, so for that Jupyter lesson, there was a quiz as well, issued out with about, so I see about average score is 88%. Okay, high score 100, okay, low score 30%. Wow, wow. Now that was only a few lines of code, by the way. Okay, average time 12.54. Okay, you spent too much time on doing this, apparently someone. Okay, we'll go through the questions and answers as well quickly. Why is data visualization important for data analysts and scientists? Come on, it aids in interpreting data and identifying trends. That's a bit straightforward, I think. Uh, to visualize, basically visualizing your data, the importance of visualizing your data, basically. Okay, it helps store large amounts of data. You can see all the others are out of concept as well. Which type of plot is most suitable for showing progress over time? I think we've seen Benjamin as well yesterday showing us all the different the plots that we can use to visualize the data as well as the differences as well. So for this question, basically the one that's basically gonna show you true results and it's not gonna lag is obviously the line plot. The scatter plot, I wouldn't say you can use it to show progressions over time. Basically that's gonna force some kind of relationships and variables as well and all that. The main goal of the bike project, basically this was just to identify relationships between bike sharing data and weather conditions, basically. I think Benjamin also shows different relationships as well yesterday that you can try and see if there are any relationships as well, you know. But the main goal of this yesterday of this project was just to identify the relationship between bike sharing data and as well as on weather conditions. Okay, so that was the correct answer, about 95%. Okay. Okay, to build machine learning models. On the bike project specifically to analyze the information. Okay, 3%, 10 response. Okay. Which tool is preferred over Matplotlib for interactive visualization in this project? So Plotly, of course, is the preferable one. Matplotlib, I won't say. I think Plotly you can. It's very. I think it's interactive. But then that's one of the main reason and importance of it's an interactive visualization tool that you can use as preferred to Matplotlib. I think just a static image or something Matplotlib as compared to Plotly. Plotly, you can zoom in, you can just slide and see like as we've done. So what is the purpose of converting date strings to datetime format in the data cleaning steps? Okay, straightforward as well to make data filtering and visualization easier. That's straightforward as well. In order for you to be able to filter, you just have to make sure that the data type of the fields that you are going to use, that's why we have to change is functioning as well to make sure that the ask type is Boolean as well, to make sure that when we filter, we get the correct result as well. The importance to use a scatter plot for visualization, weather versus rentals. Again, to identify a relationship between two continuous variables, that as well is a bit straightforward. Okay. What visualization method is used to show the relationships between rental and season in the data set? Okay, that one line plot. 34%, 54%, 52% of people saying bar plot. I would love to know why, and maybe love to see you try as well using the bar plot. But yeah, the correct answer was line plot, you see. So yeah, that's about it. Let's check the last one. Oh, three. Okay. What is the advantage of using interactive tools like Plotly for data visualization? Okay, the correct answer, at least a lot of people got that one right. They allow for detailed exploration of the data. That's the correct answer. If maybe you need to know more about the other answers that are not correct, you can just Slack me. We can go through it, and maybe you can see the differences of the answers as well, like the results of the answers. Which of the following was a recommended data cleaning step for the biocredential project? Convert categorical columns like is holiday to booleans, is functioning to boolean as well. Uh, that's what we went with. Okay. What kind of data visualization is best suited for displaying rental counts over time? I know best by now you will be using a lot of line plots. Okay, so that's about it. Not bad at all. Uh, but again, the main point of this exercise, this lesson, I think you just have to take the main point of having these sessions, and you can just take and explore on your side as well how to use Jupyter in terms of visualizing your data, whatever data that you want to visualize after cleaning it or whatever the case may be, and what you need to do as well for your data and what you need to visualize as well. This is just a tool that you can use as well. This is more like, because there's quite a different tools that maybe you guys have been using, but this is just another way of just visualizing your data. So yeah, that's about it. So I won't touch anything basically on bioinformatics. I think anyone who wants to know more about that can just chat with Nomli. What I can say is there were two files that normally put there on Canvas. Sorry about that. Let's do this. Okay, I don't need you now. Let's do this. Okay, let's go to Canvas. Okay, it's fine. Let's go to home. Yeah, for computational literacy for bioinformatics, you have the guidelines there to make sure that your Conda environment is working. You're setting up, you're configuring your Conda environment. You can go through the steps. If you run into any issue, you make sure that you state your issue and state your problem. You take a screen snap, a snap if you want, attach it, add normally on Slack. That's only if you are interested in uh in finding more about the session as well as well as for the environment as well. Quite a lot of people had issues with Windows environment. You can also attach your screen snap and also find out more about that as well. So yeah, that's about it. So those are the steps as well. To set up your environment, you go through the steps step by step up to, and then on the next one, if you check on Snap, there are files that you can use for your demo as well. So another thing normally went yesterday is the file, I think for the demo as well. So basically the demo was just to show you that, guys, as it was mentioned before on the RSE uh, what do you call this, a presentation, it was mentioned that there are research, let's say software developers that develop these scripts, not always you have to develop your own script and you have to develop your own pipeline. For example, there's someone that has created that for you, but you can do it. One of the reasons for this coding summer schools as well is to make sure that you understand Bash, you understand Python. So once you deal with these scripts, you see these scripts, then you already know where to change your variables. If you need to change variables, you need to know where your placeholders, you need to know. People had issues with semicolons, people had issues with exclamation marks. But once you understand Python, once you understand Bash, you'll be able to go through a script that normally went through yesterday to show us. But at the end of the day, the main point of that was to show you that, guys, there are scripts developed, there are scripts that you can use, as well as for your pipelines, and as well as for your ETL, basically, as well as for your to visualize the data and come up with results as well. So yeah, that was the main point of yesterday. But if ever you have more interest in bioinformatics and all that, I think normally is available. So yeah, that's about it on my side. I will check if there are more questions. I don't see any questions on chat. So yeah, Benjamin is gonna go next. It's gonna take us through today's sessions, which will be best on the PowerPoint. Okay. 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 Thank you very much, guys. All right. Close the admin. Just close this one so I don't confuse it.
Good morning, everyone. Please let me know if you're all ready. All right, I think we can continue. So we go into the slight change in this morning's schedule, just based on yesterday, and the responses that I saw on the chat, which was encouraging for some and disappointing for others. So I have a slide here that I created this morning as I was thinking about how I should respond to certain people's comments. And I thought, let me use this as a teaching exercise for everyone and discuss what does it take to be a programmer. So if you have a problem, you yourself should find a solution. This is not just being a programmer, but with any problem that you have, you should try and be self-sufficient and be proactive and find the solution for yourself. Especially as a programmer, before this past few years we had AI. Before that, we had to figure out how Python worked or solutions worked or libraries worked ourselves, going through documentation, and we had to struggle and find a way out. We didn't have perfect looking solutions from AI. We had to figure it out ourselves. And in that sense, we learned and we grew our experience in that skill because we were able to find the solution ourselves. And that's, as I mentioned before earlier in the week, a worrying thing I have, or I think about for people that are coming into programming that are relying on AI alone, that they do not have that experience, that they do not find the solutions on their own, they do not struggle, they do not fail, and they rely on other than yourself to find the solution. So as I asked in the registration, will AI replace you? But predominantly everybody said, no, AI won't replace me. We need human skills and action and insight. But my reply to that is always, okay, fine. If you don't think AI will replace you, can you replace AI? As in, can you do the same work that AI is doing? Can you find the solution? Can you struggle? It might not be as perfect, might not look as nice, but you've at least gone through the work and effort to find it out. So that is just a key insight that I think is important to understand, especially you are competing with AI. That is the end of it. And the only way to be better than that is to learn these skills and work through solutions and find a solution yourself and to make the effort and fail and find solutions to problems and not expect everything will look perfect or just complain or not be proactive. So this is my first comment: is if you have a problem, you find a solution. You try to work it out, and in that process, you gain experience. You gain XP points, like in a game. Every time, like how many times I made a mistake. You saw how I coded. I made a mistake and I went back. But each time I'm actually gaining a little bit, and you coding along with me, you are gaining that experience and exposure. So that's my first comment. My next comment is I went through all the comments from yesterday after the presentation, and I just wanted to highlight one important thing. In the first comment that was created in Slack, there was Slack rules, and these also come to a code of conduct that we try to establish. An important thing is one of the ones I highlighted there is to maintain a professional and respectful tone in all communications. So unfortunately, there was one student that did not meet that criteria. The student was warned, as was a champion, and that message was deleted. And I just wanted to reiterate, we are all trying to share our skills and our experiences with everyone, and we just try to keep professional and respectful tone. And this is general life lessons as well. And we will not, we'll make sure that everybody is respected in this coding summer school. So just take note of it. things did not go as planned as yesterday, but take it as a learning lesson. And I'll speak about more of that in the next slide. So going through the comments yesterday, there were two groups of people. There were the dedicated students, the students that saw, okay, this isn't going as planned, but what can I take from it? What can I learn from it? How can I find a solution to the problem? It didn't work out, so what am I going to do to find out, what might work, what might not work? And in that you find maybe something new, maybe something different you don't know about by finding a solution to a problem that is confronted in front of you. Then unfortunately you get the complainers that just sit back, don't do anything, and just complain. And unfortunately, they don't learn anything from this experience. So again, this is a general life lesson, not just for programming, but always try to find a solution. Things might not always work out, and it's important to rather be proactive than just complain about, what might be happening. Week 1 is not equal to week 2. So in many aspects, I have made week 1 quite easy for everyone. The content should be straightforward for you to follow. There might be new things, but hopefully it should have been quite straightforward. There was no theory to cover. You're pretty much coding along with me, taking the content, the code, and trying to maybe learn some tricks and tips here and there, maybe to find better ways than what I showed you. But hopefully you engage in some way or form. Either you learn something or you thought, okay, maybe I can do something better. A better approach that I did. But week 1 is not like week 2. Week 2, again, is a machine learning focus. And machine learning itself isn't an easy topic. It is a foundation of AI, and AI is coming up to a trillion dollar business. If it was easy, everybody could do it, but they can't. So learning about machine learning next week, again, is the foundation of AI. So if you couldn't follow this week, you struggled this week, just expect next week is going to be far more challenging. There will be theory covered to understand the basics of machine learning. So just take note of that. Week 1 was meant to be a lot smoother for you to kind of just get into the swing of things. But week 2 is going to pick up the pace and more content will be covered and theory as well. So are you a keyboard warrior? Something I want to end with. Today was supposed to be a bit easier content that we covered today. I was planning to do a Bash game, just to recap our understanding of Bash, but just in light of yesterday, I'm going to rather to cover some skills in Conda, installing a Conda environment and installing WSL, which is a Windows subsystem in Linux. Because what happened yesterday is a specific domain installation, and your domain will have specific library requirements. So I'm rather going to focus on that this morning. Hopefully, there should still be time to play the Bash game, because that's what I wanted to cover a little bit. There are some useful skills to learn from that. But yeah, so are you a keyboard warrior? That is just to emphasize, typing and practicing is the skill that you need to focus on. And hopefully we'll benefit from all the coding we've done this week and next week. So on Canvas, I very quickly constructed a page for you, which is available, which we'll go through now. You're a student, click on Summer School. So there's a page here called 5.0 Conda, Env, and WSL. So we're going to speak a little bit about Conda specifically. Again, in the prep course, you were supposed to install Anaconda itself. Now we're going to try to teach you some of the usefulness of Conda, and why do we want to create a different environment. N stands for environment, to kind of isolate different projects or different domains that you're trying to work on. So when I showed you to install a Streamlit, or I think Plotly as well, that was on Wednesday, we all installed that on Anaconda's base environment. So Anaconda itself is installed with its initial environment, and you can play around there. That should be your environment where you just play around with. But when you start working more seriously, especially if you want to develop pipelines or work on clusters and whatnot, you should try to create your own isolated environment, isolated in terms of the Python version and the libraries. You can go a step further, creating Docker containers, but we're not going to cover that in the coding summer school. But creating environments is not unique to Conda. You can create Python environments as well. It has built-in environment creator as well, and there are other tools. But Anaconda makes it quite nice and easy to separate creating environments specific for your domain. So I'm going to show you simply how to get familiar with the Conda environment. I'm listing all the libraries that are currently shown there, creating a new environment and specifying the Python version. So that was the one thing that was actually missing in the notes yesterday, was specifying the Python version, because Python version links to a library. So certain libraries might be deprecated or not be updated. But if you can specify the Python version, then it's locked down to that version and this library. So we will cover that this morning as well. And again, this hopefully would apply to not just yesterday's demo, but also in other domains that you are covering. So this should be live, so you should be able to access it. Let's go for any quick questions. Why does my code in Jupyter Notebook require pandas? Okay. If we are on Linux, do we just use normal terminal? Yeah. So there's one note about the demo yesterday, that Bioconda specifically works on Mac and Linux. There are hacks to make it work on Windows. So that was one of the issues. So I will show you today with WSLs how to get it to work. But Christoffel, if you are using Linux or Mac, the demo and the instructions from yesterday should work in a straightforward manner. So let's first open up our command prompt. You can open up, if you go search, you can type Anaconda prompt, or you can go to Navigator. So I think the Navigator is here too. So where is your prompt? This one here. I'll launch. So if you click on your PowerShell, your Anaconda prompt, you have Windows Terminal. Should be fine. Should be okay. All looks the same. So this is what you should see when you open up your terminal. You should see base, and you should see the full path where it currently is. So the key thing to note is if you see base, it means your shell, your command line has Conda environment activated, and on its own, it has the base environment already up and loaded. So if you want to, so here already you can see the libraries that are installed in this specific environment, but we want to also create a different environment and specify different Python versions. So let's make sure you have this running. I'm going to just maybe zoom that out and make sure I have this window open so we can work with both. There we go. All right. Okay, there we go. So first click on Anaconda prompt. You can go on your search, search for Anaconda should pop up with prompt. This one says Miniconda. You can do either one. Your one should just say Anaconda prompt. What does your one say? You install the normal one, right? So it should just say, yeah, it should just say Anaconda prompt, which is fine to use. And again, you should see base, right? That's the thing you should see. All right, so let's do conda env list. So I want everybody to type in your terminal conda env list. And this lists all the environments that was created for whatever reason. We can see there are three environments. Two environments. There are two environments that was created on this machine, which is a base, which is installed by default, and this is the one that was installed yesterday. Bioinformatics demo. You can switch between environments by using conda activate and the environment name, but we'll come to that shortly. So to list all your environments, again, you might have different projects you want to play around with in different Python environments, Python libraries. This is the best way to isolate your Python environments and to work with it. So in my machine, I have probably about 20 different environments I have for different types of projects, just to isolate that to make sure it always works in different situations. So, all right, so next thing is just to look at, okay, these are my environments. Next thing I want you to see is what are all the Python libraries that are installed with the base, the one that comes with Python already, or with conda already. Somebody wants zoomed in. So type conda list. If you just say conda list, it shows you all the libraries that are pre-installed and the ones that you installed as well. So just wait for that to load. And you have a whole bunch of libraries. And we should see Streamlit here as well, because I'm assuming, there we go, there is Streamlit. So this was newly installed, as you have all done already. And if you zoom out, there's a long list of pre-installed libraries that you can see. Yeah, there's a long list of pre-installed libraries. That's why we prefer Anaconda, because you don't have to install a lot. Pandas is here, and NumPy and everything else. So it makes it quite nice to use. All right. So conda list, that lists all the libraries in your existing conda environment. Today's lesson was about bash and work on the terminal. And this is a really important skill that you as a data scientist, as a researcher have to learn. I'm always in my mind thinking AI is a competition of what skills do I need to know to make sure I can compete with it, and bash is definitely one of them. Knowing how I can control things on a terminal is by all means a very important skill. If you want to connect to a server, if you want to a cluster for whatever reason, it is almost by default, you have to know how to work on a terminal. That's why today specifically, or this morning, was working on a terminal. So you should be comfortable with the terminal. And the prep course, you did get an intro to bash, how to create files, move around files and whatnot. So should be comfortable working in terminal. But this is a lesson in conda, so also working in a terminal. So let me just clear. If you have a lot of text, if you want to just clear, just have a top line, just type in clear. And it goes first line. Nathaniel asks, please, what is a simple way of defining bash? So does anybody know the definition of bash? UCT, what does bash stand for? Born again shell. Bash stands for born again shell. Thank you, David. I did beat you to it though. So it is wait, this was actually taught to you in the prep course, so maybe you should look at that again. But it is a terminal that you can operate in your you can use in your operating system to run specific commands. But Nathaniel, rather look at the prep course. I don't want to cover what is bash right now because that was a reason of the prep course. Paco, the difference between creating a new environment and creating a virtual environment, is that the same thing? Yes. I wouldn't say virtual. I mean, everything's virtual in some way of the form, but we're just creating a new environment, Paco. So yeah. All right, so where were we? So we're looking at all the libraries. We were looking at the libraries. So yeah, that's what I wanted to show you. So we have a long list of all the libraries installed already. Okay. And we were able to find Streamlit, what was there. Now what we're going to do is we have a certain project, whatever the project is going to be, and I'm going to create a clean conda environment, which is completely separate to this environment. And the important thing is to specify a Python version. If you don't specify a Python version, it relies on the base version. And that also, I've seen many times, it has conflicts with your libraries. So just to have a clean, separate environment, specify the Python version. It's like creating an isolated Python environment every time. So to do that, we're going to create an environment called conda create in CSS 2026. Specify the Python version 3.10, which is still stable, and Y. So if I type enter, you should see it is starting to install the packages from different channels that we will be using. So this might take a few minutes. So we'll kind of wait for that to install. So again, this is create a clean environment. You can specify whatever name you want. So it doesn't have to be CSS 2026. See, these are all the libraries it is installing. So this is it. There's no Streamlit here. There's no pandas. There's no NumPy. There's no matplotlib. There's none of those libraries. So you have to install those libraries again. Yeah.
There is specific platform assign this one that I want to study 3.7.
Whichever one. 3.9, 3.8, 3.7. You can specify 3.9.2.5. I think 3.12 is probably the latest one. But 3.10 is still stable, so I just chose it. I chose it also because it's still stable with bioconda, which I'm going to show a bit later. So yeah, so that's it. It has been installed, and it tells you to activate this environment. We just say, we type here, conda activate CSS 2026. And what you should see is this base changes to CSS 2026. And that's it. Now my environment is isolated. I'm running Python 3.10. And let's check out what libraries are there currently. Conda list. And if I zoom out here, that's it. No pandas, no Streamlit, no NumPy, NumPy, no Plotly, none of that stuff. This is all that we have. So again, for your own projects, this is what you should start off with. And you start building on your libraries that you need specifically. There are ways to, for example, you've built this locally on your machine, you can now take it to another machine or on a cluster by creating an environment YAML file, which shows the steps to create this. So that's another process to do if you want to use it somewhere else. Take this environment as is and put it somewhere else. So this is my environment created. Again, you can create whatever environment you want, but this is usually the base libraries that you have installed. All right, we've activated it. So this is a clean environment. All the libraries we installed, like Streamlit, Plotly, Spider, even Jupyter is not there. Spider is not there. You can't run Spider here, it won't work. Again, so we check the libraries, that's all done. Now, just for demonstration purposes, I'm going to run Streamlit, because obviously Streamlit is not here. So I'm going to type out Streamlit, pip install Streamlit. To install, for example,
Just use port installing.
sure. So what is the okay, let me just say, okay, let me just break this. So let's say Streamlit hello. Right, that was the first command we learned with Streamlit. Just to make sure Streamlit is installed and our browser pops up. So that worked with base before. Let's see if it works here. It does work with it. Okay, well, it's on the same terminal. So that's why it's popping up here. Yeah, it's the path is saved on your command line, so it will still run. But other libraries, for example, if I check, stop this. The path Streamlit is saved. That's why it will still work. How do you works? Process it. We'll see. Let me close this one up. Let me close this because my Control C for some reason is not working. Control C, exit. Let me just close this again. I'm going to open it as well. Let me go to my navigator. Sorry? Pandas, or Pandas version. Yeah. Pandas hello won't work in any case. So let's get back here. So what was the command again? It was conda activate CSS 2026. Actually, I just want to show another example. We say Python. So we can see the latest Python version. This is if you want to run Python in a terminal. It says here it's 3.13, right? Okay. I can import pandas. Should work just fine. All right. Now, if I say conda activate, this is 2026. Python. It specified the latest Python 3.10 version, which is 3.10.19. And if I type pandas here, what pandas, it says no name or module found. So this is what you should expect when you're installing things. But just for the sake of practicing, I'm going to install Streamlit here in this library, in this environment, pip install Streamlit. Quick question, please can we see the command you use for installation? It is on Canvas, so you should just follow Canvas along with me, which is, yeah, just follow the commands over here. So if you're stuck, then just follow it. That's busy installing Streamlit. Another question from Makafani. What is the difference between installing pip? Patrick's did. Pip, conda, and sudo. So conda is specific for conda environment. It uses conda's channels or certain libraries to package the Python files for you. So in some instances, it is better to install things. What was that? to install things with Conda. For example, Spider or JupyterLab, you should use Conda to install things. pip is generic Python installation library, or a tool to install various libraries. So it is your default tool to install libraries in Python. Sudo has nothing to do with installing Python libraries. That is a bash command to give you admin access in your bash terminal. Okay, so let's check if my Conda list again. Conda list. I wonder if you've got git bash as well. Let's have a look. So just by installing Streamlit, it installed quite a bit more. Libraries that are dependent on Streamlit installed NumPy for me. It installed Streamlit as well. Install Pandas as well for me. And a whole bunch of other libraries. Pillow is used for images, managing images, a whole bunch of other stuff. So now if I type Streamlit hello, as we expect, should open up the thing we saw before, allow, and the same Streamlit application we showed you on Wednesday. Interestingly, my Control-C is not working to stop this. Let's see if it works in Bash. Let's see. Conda NThist. Okay, it's not. Okay, let's install it. Okay, so that's it for now. We'll continue, but later you can go through the notes. I just wanted to show you how to be familiar with creating Conda environments, looking into libraries, isolating your different Conda environments as well. It's very important. Next, we're going to look at Windows subsystem for Linux, how to run a little Linux environment inside of Windows. So we're going to go through that. It might not work on everyone because you need admin permission on your machine. So if you're on like in a lab PC, for example, this might not work, but I'm just giving you the guideline if you can run it on your own machine. So we'll show you how to install it, install Ubuntu, and then start working with it. And then we'll go through steps on how to set up the bioinformatics environment like yesterday. But yeah, we have the tea break now. We'll continue after the break. All right, let's begin again. See who is ready. There's a few questions that popped up in the meantime, so I can go through that. While we're waiting for thumbs up. Courtney Brown, can you please demo how to do the upcoming Ubuntu setup for Mac? If possible, is Ubuntu going to be required for the Earth Science demo later today? No, it's not. There are just two libraries you need to install, which is quite straightforward with pip install. I tried it myself, so it shouldn't be a problem. And secondly, you don't need to install Ubuntu on Mac. Mac itself has a terminal which is very similar to what you get in Bash. So you don't need to install Ubuntu at all, or you actually even shouldn't. They are very similar environments in that sense. So you don't need to install Ubuntu at all for the demo today, or you shouldn't install Ubuntu on Mac in any case. After running Streamlit, I was taking the web command, web tab for Streamlit, but the command prompt does not show anymore. How do I go back to the other commands? You can do Control-C to stop the program, or Control-Break if you have Control-Break as well. Sometimes it helps. I think I responded to everything else. So let's see, have you created your own conda env yet? Let's see. Have you created your own conva environment yet? See if you get any thumbs up, thumbs down. A very important and useful skill. Spot on. Cool. All right. So some people are getting the hang of it, which is good. All right. So where were we? After Canvas, we did environments, and then we spoke about WSL. So this is a useful to have Bash, to have a Linux environment on your Windows machine. In the prep course, you did install git bash, which is useful. You can run bash commands in Windows, but it's not an actual Linux environment. So most things you can do, most commands you can do there, but this is an actual Linux environment that you can install. So how to do that? You go to your Microsoft Store. Again, not everybody could possibly do this. You might not have permission, need admin access. So this is only for those use cases, or people that can do it. So let's go to the Microsoft Store. And type in here Ubuntu. There are actually many Linux environments you can install. Ubuntu is the most popular one, easy to use. There's Kali as well. There's also CentOS. There's quite a few. I think CentOS you can get to Alma 9 as well. So you can get quite a few Rocky. But we'll use Ubuntu. It's quite user-friendly, so we're going to use Ubuntu. Ubuntu, click on the first one. And it says install a complete Ubuntu terminal environment in minutes with Windows subsystem for Linux. It is your own little Ubuntu Linux in Windows. Very cool to use. So click on get, it'll install the libraries. So you did 2.24. Okay. Somebody says, I got an error, has not been enabled. Donald, so you probably, that's a Windows setting you have to sort out. So I'm not going to debug these problems because it's sometimes can be quite unique, but it's something you have to enable in your system's file if you do have permission. But you can just Google it as well if you want. So that's installing. So let's carry on. What else? Once it's installed, click on open. So you can go ahead and do the steps on your own. If you want to try installing Linux on Windows, again, you don't have to do this. I'm just, this is a useful to have if you want it. So it's almost done. So then you click on this get should change to open. Once it's done, it'll open up a new little terminal for you. It'll say installing. This may take a few minutes, and then it'll ask you for a username, password, type of password, open. Okay, there's my click on open, change to open. Then here's my terminal. I think this was probably when you installed already. But yeah, you should see something like this where it asks for username and asks for your password. So you can do that steps in the meantime. And then you should see something like this. So we'll create his one with his initial and surname. So this is what your environment should look like. This is an actual Linux operating system running on Windows. So let's check if Python is running on here. You can type Python. Okay, it doesn't like that one. Let's try Python 3. There we go. Okay, so Python is running and it is working. So version 3.12.3. And let's just get a feel, is this an actual environment that has that is bash? So let's see if I can do some line or bash commands like ls. Okay, ls works. What other bash commands can everybody remember? Johanna says, is it possible to use Kali Linux? Yes, you can use Kali Linux if you want to. David says Arch is superior. It's it's there are pros and cons. Ubuntu is far more user-friendly, but Arch has benefits. Kali is more for security and cybersecurity purposes, as far as I know, but you can use it whatever you want. Christopher, I use Mint. It is nice. Yes, Mint looks like Windows. It's based on it is based on Ubuntu as far as I can remember, or I think it's Debian based. But what other commands can I try out to make sure that I am running bash? What commands can I run? pwd, okay, that's a nice one. pwd tells me print my working directory. I have cd. Cd works in a Windows command prompt as well, so not really cd. lsl, that works. ll, so all these things, so we should be familiar with that. So any other commands that you can give me? Maybe check the version, lsb_release a, something like that. There we go. So this confirms I am running Ubuntu version 24.04, the latest release, the latest stable release. Echo hello world. There we go. Great. Nice. These are nice commands. So echo hello world. Good. And I can say which Python there. And how about, does this work? Who, why? No, what's that? What was the thing again? Can't remember. There was these funny commands you can do in Bash that gives like these funny characters. I can't remember what it is. Like, who am I? That tells me just the username is. Okay, all right. So cool. We know this is Ubuntu now running on a Windows machine. This is pretty cool. All right, so it's good practice to always do an update, whatever you want to, another command, dfh, check out the memory. You have a sneak peek in your machine for you. Okay, that's enough of that. So next thing we want to do is this, just to update and upgrade, a good practice when you ever start a new machine. It's confident. I'll look away for you. I'll look away.
It's fine. It won't be written there. So in any case, let's hope it's right. There you go.
No, I don't need it again. It's fine. Okay. Cool. So it's good practice to do sudo updates and sudo upgrade. And just make sure all the packages and libraries are all up to date with the current version that you're running before you want to install anything else. So it's always good to do that. So what we're going to do is we want to kind of copy the same environment we have on Windows machine where we have an Anaconda. So the steps you did with the prep course was showing you how to install it with the installer and have a navigator, but you can install a very basic terminal version called Miniconda, which is just runs on the terminal. It doesn't comes with the bare minimum, just so you have a conda environment ready, and that's what we're going to do. So again, if you go into Canvas, you can just copy and paste this command, paste it here. Too many arguments. PD. What is wrong? Right. wget. Oh, wait. Okay, should be, hopefully it's fine. So two separate processes we're supposed to do. Yes, David, I forgot that. Cool. So now that's installed. So let us see if we can. So all we did was wget. This gets the installation package from the internet. Now we still need to install it. Install it by saying bash file name. A whole bunch of stuff you have to agree to. Implementation, that's fine. It already exists. Okay, so it is already here. So we already created it before, but running this command, what is it again? Bash command will install that location, will install the Miniconda to environment. So I can follow that step. The next one to run it, let's just see if it actually runs with conda env or not. I'm not sure if it's initialized conda list. No, so that's manage with source. Okay, so next command is just to initialize it so it runs in terminal. Yes, Donald, so just run this command. I made a mistake there. Just run version. All right, so let's see if Okay, that initialized conda. Let's see if it's in your environment in bash. So let's see if it's there working. Conda version. Yes, it is there. Let's see now if it works. I'll see my conda environments. And it is there. We just have one environment, the one that is installed by default. So that's what hopefully you should get. Let me just make a correction here in the file while we're at it. So who has WSL installed? Who has WSL installed? That is the Ubuntu WSL. So a few people have got installed. Okay, cool. All right. So next step in the process, that is a conda environment. Now we're going to follow the same process or the steps as yesterday. One thing we should do is to, before installing anything, I found you have to accept these packages to use different packages. So I can see these commands. Belinda, is what you're currently doing solely for Linux, or can you still proceed in Anaconda prompts? You can. This is for the situation if you want to do the bioinformatics demo specifically, you need WSL as a workaround, Belinda. And it's a good practice as well to run projects to test things that only work in Linux, like Ubuntu. You can use it. But you don't have to use WSL. You can stick to Anaconda, the one we've been doing for the whole week. This is just an extra skill, extra tool you are learning. That's all. You don't have to do this at all. Just listen in. Right, then you have to add all these channels. I'm going back to my guide here. Okay, other channels. All right, and then we have this final command. Which installs the bioinformatics demo. Accepted. So it's ready. Check it. Running command. So is it that it's ready? Okay, anyway. So it asked me just to accept this change here to override channels because I'm using Bioconda. Okay, and then let's try it again and run that same creation of environment. So this creates bioinformatics demo environment with Python 3.10. And there's various libraries you need for bioinformatics demo yesterday. And it's also installed Spider for you because obviously there's a completely new environment that you can work with. Yeah, that might take a bit of time, installing everything. So while that's installing, let's carry on. And then you can activate that environment and follow on the same process that you did yesterday, or the same steps that you did, or the guide from yesterday as well. So I'm not going to go into much more depth. If you have questions, you can ask normally about it. And Conda activates, there we go. So there, everything's installed correctly, everything's happy, all the libraries are there. So activate it. And now we can check, what was that one? Library that gave problems was, yes, duplicate version. Non-flag, is it maybe 1B? Let's see. Well, it's installed because it's giving me other flags. And an error. Could be a version sense, I don't know. I saw it. There we go. This just version on its own. Okay. Version. There we go. So this confirms that it installs successfully, and you can carry on with the same tutorial that normally showed you as well. Yeah, so that is just a guide for yesterday. To prepare for this afternoon's demo, the Earth Science demo, you'll just be needing 2 libraries. So you can install this quite easily with XRN and Cartopy. I think Refilwe should be sharing the notes shortly before this afternoon. So I can already get ready, but you just need these 2 to install. You can do it in your base. You don't have to create a new environment. Again, because if you want to do it that way, you're gonna have to install pandas again, you have to install Spider and everything. So just install it in your original base environment, and then it should still work. Plotting, one note I have about plotting as well is by default, Spider plots inside of the window. So this is just a guide to show you, how to make the plot pop out as an actual window. Yeah, and that's actually it. That's the demo or the environment I wanted to show you to get it to work. So let's see if on the questions here. When I get the Anaconda repo, it says too many arguments. Can you maybe share your screen or snippet? Conda activate, Conda found. Donald, you probably didn't create that environment. Remember, you have to follow all these steps that I've done. You have to follow these steps and then create environment. So this is the command to create it. Advance. Yeah, please can you pause a bit? Yeah, there are other issues with installing WSL. I'm not going to cover that right now. I can maybe add more notes, but later. I wanted to continue with what we meant to do today, which is becoming a, what did I call this again? Becoming a keyboard warrior. So what do I mean by that? Well, today was all about the terminal. Close this now, I need it. It's all about the terminal, and we are going to carry on with the terminal. So I want you to open a git bash. We're going to do this until lunchtime. See how far I get. There's a quiz for this, so this might seem trivial, but it is still required for you to do. So please open a git bash, something you should have ready and available at all times. Mfundo, I forgot my pseudo password. That's a tough one. That's a tough one. All right, what happened to my canvas? Where's canvas? EP, canvas.
This is better.
It's right. Is it there already?
So I was taking Canva.
Is your prep course?
Not there. I use my personal.
Okay. Okay, cool. So your student. So please open Git Bash. Is Git Bash open? Is Moby Xterm okay, or does one need Ubuntu? Moby Xterm is very similar to Git Bash. So I'm not sure what you want to, you mean for this exercise, you can use Moby Xterm, it's fine, but Git Bash is a bit more Bash friendly, more Bash native, more Ubuntu native. So I'd rather say use Git Bash, but it should still work. It should still work for exercise today. So please open Git Bash. And let's picture ready. Let's share the screen over here. Terminal. Okay, cool. All right, so there on Canvas, if you go to Canvas, there is another page called bash crawl. And what is bash crawl? Okay, so bash crawl. Make sure you have a bash terminal up and running. It can be Windows, Linux, or Mac. For Linux, you can use a normal terminal. For Mac, you can just use a terminal. PowerShell doesn't really work, so I wouldn't recommend it. So all I want you to do is open up your bash terminal and git clone the following. If you don't know what git clone is, just copy and paste this line, go to git bash and paste it. Enter. Okay, already exists. So once you've done that, go to cd bash crawl, cd bash crawl. cd bash crawl, and then you can type ls. And in ls, there are two files and a folder. And a folder is an entrance to a dungeon where there are monsters and dragons and potions and treasures you have to find. Hopefully you can survive the bash crawl. All right, first thing to understand how to survive this dungeon, you have to read the README file. And how do you read the README file? Cat README, MD. Okay, let's try it again. Cat README. All right, so what does it say? So this is a game to teach you the basics of using POSIX, Linux, BSD, Unix terminal. If you haven't downloaded it, you can do it here. We've done this. Okay. To start playing the game, open up a terminal, done that, type the letter CD, done that, the spacebar, then drag and drop the entrance directory from this folder into terminal. We don't need to do that yet. Done. The next thing you have to do is go to entrance. So we're going to do that together. We're just reading through this. Your first move is very important. The first thing you have to do is read the scroll. So to read a scroll, cat scroll. You are now playing the game, may the God save you. So restarting the game if you die, if you run out of health, if you played, if the monsters ate you for a reason, if you didn't have a sword to destroy the monster, then your health will deplete. So to start the game, you trash bash crawl and have to start again. There's some comments about how to use this in Mac OS and whatnot, which I won't cover. So now you're in the game, let's have fun. All right, let's clear this again. I will guide you on the path, but leave you alone after that. So let's go CD entrance. What's inside that? LS. All right, so we have the cellar, chapel, scrap, scroll, and vault. So let's read the scroll. What does the scroll say? It's a pitch black in these catacombs. You have a magical spell that lists all items in a room. To see in the dark, type LS. To move around, type CD and the directory. Try looking around this room, then move into one of the next rooms. Example, LS CD cellar. Remember to cast LS when you get into the next room. That's it. Have fun. So I know everybody's having a lot of fun trying to get through the catacombs and surviving the monsters. There's a few announcements to make before lunch, which is about 20 minutes. Yeah, so please complete this game as far as you can until lunch. You can, after lunch or whenever you want, try to complete it until you win. There is a quiz for this game. So Python quiz 5.1, there is a quiz. So you have to do that as well today. And also the notes for the Earth observations data is there as well. So you can have a look at it and prepare for that for this afternoon, where we feel we'll be doing the demo this afternoon. But yeah, carry on going through the catacombs and the dungeon, and we'll chat later. Galet-san asks, can a Mac user please help me install the bash terminal? Please do not install the bash terminal on a Mac. You have your own terminal called the Z shell already, so you don't need bash if you're running Mac. Cynthia is going to respond to that, and she will help you. Cynthia will guide you. She has volunteered.
Message. That's fine.
Yeah, well, there's no pin message.
This dots. Does it organize?
Oh, it wasn't there before.
Hi, Violetta, can you hear me?
Hi, Rafina.
Hi, can you hear me?
Yes, I can hear you. Can hear you.
Awesome stuff. Okay, let's
Will you be sharing your
share
screen now?
the screen. Yes, let me share.
Yeah, I just gave you permissions now to be a panelist so that we can test this. Because I think the guys are on lunch as well. But yeah,
Yes.
let's see.
Let us see. Wait. Where I needed to first check because now I don't know where's my screen.
Okay.
Screen 2. No. This is screen 1. Okay. Share.
Okay. All looks good.
Okay, let me see the present. Yes, that looks fine, I believe. Yeah.
Okay, looks fine on my side.
Yeah, it looks okay on my side. So when I finish with that, this will be on here. Yeah, you're good. Okay.
Okay. See you at 1:30 then.
See you at 1:30. Thank you.
Yeah,
Bye.
you can just check on the chats as well with the gents if they are ready at 1:30. So you can just
Okay, I shall.
just check the number of
Thank
reactions
you.
or just proceed.
All right. Awesome stuff.
Okay, cheers, man.
Thank you, Vioba.
You can stop if you want refill your sharing now, then you can just share later on. If you want though, but it's fine because
Thank you. I couldn't find the Zoom window.
Okay, hi everyone. Okay. Okay, afternoon. Hope everyone is back. Let's just react on Slack so they can
Hi
begin.
everyone. We have one thumbs up and a one tick. Okay. We have 16 people ready. Maybe we should give them 3-4 minutes. Okay, hi everyone. I think most of us are back from lunch. So I'll just start. So my name is Refilo Kai, and today I'll be taking you through the Earth observations data demo. But before we do the demo, I'll be taking you through some theory just for your information. Take notes, don't take notes. That's right. So as the first slide says, I'm an atmospheric scientist, hence the chosen data for the demo. And in atmospheric sciences, in our research, we use files such as NITheCS, GRIB, and HDF regularly. And you can obviously tell what type of file you are working with because of the extension of the file. And NITCDF has .nc, your GRIB has .grb, and the HDF file has a .hf. So on the slide here, I have given you the different types of files or what they are called in Python and in R, and that's because I use R also sometimes for my analyses. So these type of files that I've mentioned, and others that are not mentioned here, they are robust containers, and they're used for storing atmospheric data, including meteorological data. And this allows for researchers to analyze and visualize different types of data sets effectively. And in this demo, we will be using a .nc file. So this is an example of what a .nc file can have in it, a summary, basically. So we can see that this file is not a flat file, such as what an Excel or a .csv file would be. It is multi-dimensional. You've got, in this example, you can see you've got coordinates, and under coordinates, you have other different variables, and you have also your data variables, which we would call products. Right. So for analyses, we often use packages like NumPy, Pandas, and Matplotlib. We've heard a few things about NumPy, and I think we all know that it stands for numerical Python. So NumPy provides fast and efficient operations on arrays of any dimension. So it could be 1D, 2D, or 3D. And atmospheric scientists use this package to manipulate large data sets from satellites, as we're going to be doing today, weather models or observations. For example, we can also calculate mean concentrations of pollutants like NO2. And in this picture here, we can see we calculated temperatures in Australia since 1910 to 2000. And we can also perform statistical analyses on gridded data. Pandas, on the other hand, is a library designed for working with tabular data. Tabular data are similar to spreadsheets, but are far more powerful. And this is commonly used in atmospheric science research to manage time series data, such as our hourly air quality measurement or meteorological observations, which sometimes can be collected every 10 to 15 seconds, depending on what you're measuring and what the aim of your research is. And then we have matplotlib, which is for plotting. And it allows us to create publication quality visualizations. So there are other packages, but these three libraries that I mentioned, they form a powerful workflow, right? Because from your numerical calculations, you organize the structures of the data, and then you can plot your data. We also use scikit-learn and TensorFlow for modeling. So scikit-learn is for classical machine learning. It provides tools for tasks such as regression, classification, and dimensionality reduction. TensorFlow, on the other hand, is a more advanced library for building and training neural networks and deep learning models. So atmospheric scientists generally use TensorFlow when working with very large or complex data sets, such as high-resolution satellite imagery or multi-year climate model outputs. And then we also use tools for GIS analyses. Since we work with geospatial data all the time, Python provides several powerful tools such as GeoPandas, Cartopy, Matplotlib, and Shapely, so that we can efficiently work with these large data sets. So for time series data, we usually work with stats models and profit. So from this little information, I believe that one can see that Python has a rich ecosystem of tools. And with these tools, atmospheric scientists and other researchers in various fields can transform raw data into insights by visualizing complex patterns. And atmospheric scientists, like myself, can also make informed predictions by modeling these data. So these are just the references for some of the work that I presented to you. So in the next section, we are going to use a .nc file to plot Earth observations data. So we are going to use data file from Sentinel satellite. So we're going to use Sentinel 5P data file to plot nitrogen dioxide in South Africa. But we're just going to use 1 day of data because I don't want to have your computers crashing today. So we'll just take 5 minutes for everybody to open up their Spider, and please make sure that you have installed the packages as mentioned in the instructions that are posted on Canvas. When everybody is ready for that, please just give me a thumbs up, and then we can move on to the next section. Okay, so I've just put a message in the chat to let me know when you're ready for the coding demo. However, I'll start at 13:43. Hopefully by that time, everybody is ready. So you should have the .py script from GitHub. You should have a .nc file called no2_South Africa_demo.nc from a Google shared link. Right. So for the first part of the demo, I don't expect you to follow along because the file that I'll be using is very big. And then you can follow along in part 2, and that is the code that I shared with you. Right, so 2 more minutes. Everybody get ready. Oh, and please let me know if you need me to zoom in. Can you see the code properly? Awesome. Okay, is everybody ready? Yes. So somebody asked if we meant to download the .nc file and open Spider only. Also get the also get the .py script on the link, the GitHub link. Right. I hope this is big enough for everybody to see. Okay. So while everybody is still getting the file, we can start with the first part. Right. So the first part will be creating a subset of the data. Okay. There we go. Right. So as I mentioned in the instructions earlier, when you are saving your code and your data file, please make sure they are in the same folder, just for easy access. So the first thing that we're going to do is create a subset of the data. As I mentioned earlier, the file that we'll be using today was initially 0.5 gigabytes, and I have subset the data to reduce its size so that we can all code along and have an interactive session. So for this demo, one would have needed to install Xarray and NumPy. I already have mine, so just gonna be running that. And then we are going to open our file, the almost the very large file that we have. Great. So Xarray is for working with multi-dimensional arrays like NITheCS file, as I mentioned earlier, and the NumPy provides fast array operations, and it will be used for calculations and for masking data. So we have opened the data, and the next thing that we're going to do is print the data set. So by doing this, we are printing a summary of what is in this file. As you can see, you have about 4,000 data points, scan lines, I would say. And it's telling you basically what is in this data file. It is, so by doing this, you are basically printing the table of contents, I would say, the table of contents of the .nc file that you are working with. And generally we do this as a first step after opening the file, just so that we can see what is in there and we are able to plan how we're going to navigate and work with this type of data so that we don't make mistakes, get empty data sets, or plot the wrong thing. So as you can see here, we have dimensions, and this gives the name and the sizes of all the dimensions that we have. And then we have the coordinates, and these coordinates, they are variables that describe the dimensions, such as your latitude values and your longitude values and your timestamps, right? You have here your ground pixels, and you have your layers and the vertices of your latitude and longitude. And then we have data variables, and usually that's where we concentrate on. That's the stuff that we want to analyze. And then we also have attributes. It's not shown here, but we have attributes, and that's just the metadata of the file. So So this line here, line 18, it doesn't really do anything. It doesn't really do an analysis. It's basically just a formatting of the output so that after printing all those things from your table of contents, you can see the next output properly. So variables, your list of variables that you have in there. You have no nitrogen dioxide, you have your air mass factors, and you have the kernels. I know half of these things don't mean anything to you right now, but just showing you all the variables that we have in our data set. And we can also look at the dimensions, as we've also seen this from the summary that we did earlier. So now what we are doing, we are selecting only the variables that we need, right? This is to reduce the memory and the memory usage, and it is useful for large data sets like for today. One thing one has to be careful about is the spelling. So you need to make sure that you are spelling your variable correctly, because then otherwise you're going to have an empty new data set. Right. So we have said what we want to keep, and then we are going to call that DS again. And then we're going to choose the latitude and the longitude of where we want the data to be, right? From all this data that we have, the satellite data, which is for basically, it's a larger area than South Africa, right? So now we are just making sure that we're bounding the data to South Africa. So we are looking to work on a specific geographic region, right? And the drop through here is to say that we are removing the points outside of this bounding box, this region. So we go with that. If there are any questions in the Slack, I cannot see them at the moment. I will address them during the break. So after doing that, we are now changing the data set that we have just made, South Africa bounding box. We are saving that to NITheCS. Right. And then you'll see that, well, I already had it, but we called it NO2 South Africa demo.nc. So that is the file there. So the next line is just to say that you have created that file. So that was quick. That was just to, make sure that you know how I got this subset of data that we're going to use, right? So the reason why the satellite data are so big, the files, is because a satellite takes data of the whole world in one day. So you can imagine how much data we have per orbit, right? So for you to be able to work with it most of the time on your local computer, we subset the data so that we do not have our computers crashing, or we can use a server for that. But for today's demo, I thought it would be great just to show you that, you are able to just subset the data and work with a smaller file. So the file that we had was about 0.5 gig, and now the file that we have is 890 kilobytes. Right. So I'm going to give you guys 5 minutes, just so you can let me know that you have your file, your reduced size file, and you have your Earth Observations Demo Part 2 script, and you have opened a Spider, and we can move on to Part 2. So there's a question, was Earth observations demo.py deleted from GitHub? Yes, I have deleted that one. I just left the demo part 2, right? Just so that we didn't have a confusion of which code we are using. I can share that definitely after this so that you can do it on your own later. And then I'll also share the link for that big file. Right. So module not found error, that means you have not installed Katopi. So remember in the instructions in the Canvas note, I asked you to please install the modules that we're going to be using, the packages modules that we're going to be using. So if you have not done that, let's do that. I'll give you until 14:02 for everybody to get that going. And then please just let me know when everybody is done with that. So the .nc file, no2_South Africa_demo.nc, will not open if you click on it. So that's what we're going to be using. That's what we're going to be doing in part 2 to actually open the file. So you cannot click on it and just open it. You need to use Xarray, and that would be the line 56, which says ds equals to xr.open_dataset, and you have file name, right? So you can't just double click it and open it. Yes. So we have a question in the chat. We have an error, and it says that, let me see, I think it's an error of the file path, right? So make sure that, so I did put in the notes there to say, if everything is not under the same folder, you are gonna have to copy the file path for you to access the file. So please confirm that you have your code and your data file in the same file. Okay, so David has said, was that a different error? The plugins. So David said you should please use pip install NetCDF4. Cool. What's your new error now, Trini? Okay, so we still have 2 minutes for everybody to get on the same page. Yeah. Please do share your errors in the group so that if people have the same error, we can assist each other. And yeah. But generally, let's see how many people are ready to go. Invalid version, is this a version of the Python that you're using or invalid version of the module you're trying to download? Okay, guys, I'll just put a message in the group. Are you ready to go? Please put a thumbs up if you're ready to go. And then those that are still having problems, their tutors and champions can assist them. Otherwise, we can also help them in the chat as we go along. Okay. We have a few people that are ready to go for part 2. And those are not ready to go. I'm just gonna, start, and then I'll give you some time for you to catch up. And yeah, I don't want to lose anyone. Cool. All right. So the next thing we're gonna do is, yeah. I hope everybody can see. We are going to import X-array as XR. Import NumPy, matplotlib. So everybody has managed to do their import without any errors. Please let me know. No, okay, I do know that some of you are having errors with that, but those that said they were ready, and they have also installed their packages. No errors with imports, let me know. So then we are going to give the file name to our data file, no2_South Africa_demo.nc. Right. So this one here is just to say that it's true, we're going to make a map, and that activates our plots. And especially if you're going to be running some stats in your code, which we are going to do some basic stats, it just helps you to toggle between the plots and the other console, the console. Cool. So we run that. And then we are now opening file name, which is that reduced file data set. And then we are going to print that as we had done with the big file earlier. Awesome. Thank you, Shane. So with this file, I hope everybody got this output. Thumbs up, everybody, some reactions so that I know that we're on the same same path, same level, same page. Yes. So as you can see, for this reduced file, it is much smaller, right, than the big file that we had earlier. So for the data variables, we only have nitrogen dioxide tropospheric column. We left everything else that we're not going to use. And we have ground pixels 390, which is much less than what we had earlier in the big file. Cool. Now, we are going to select the variables based on the product type. Remember earlier when we were subsetting the big file, when we were looking for a certain variable, we used product, group product. But because now we have subset it, we don't need to use group product because we have literally removed it from that level of, or that dimension where the grouping of product is, and we have just extracted what we needed, right? So is everybody still following? Please give a reaction in Zoom or type in the chat. Are we still following? Yes, no, silence is a yes. No news is good news, right? Okay. So we're going to move on then, because I guess everybody is on the same page with me. So what we're going to do now is we are going to select the variable that we want to work with. So we have already opened the subset for analysis that we are using, which is that reduced file. And then now what we're doing is we are selecting the variable and units based on the file name. So we're using NO2. If there's NO2 in the file name, the variable name is nitrogen dioxide underscore tropospheric underscore column, and the unit labels will be moles per meter squared. And then we used an if statement to say, if in the file you have this name, AER underscore AI, then the variable name is aerosol index that. So then we're gonna label the unit that, right? However, we know that in our file, there's no such thing because we didn't select for that when we are subsetting. But sometimes when you are working with different or many variables at a time, yeah, you just put this so that you can check just in case, because sometimes a file does have the other product that you're looking for, and sometimes it doesn't. Right. So we run that. And then you have your data. And then now we are going to extract our latitude, our longitude, and we are going to extract the data for that. Cool. If there's a message in the chat, I will check just now. And then the next thing that we are going to do is mask out invalid or missing values. So by doing that, so what happens is when satellites collect data, sometimes we get an error. It doesn't collect the right data and it gets flagged. So when it's flagged, we don't need to use the flagged data, right? So we mask the data that is flagged so that we don't use it for our analyses and we don't get incorrect output. Right. So before we move on to the basic statistics, I'm just going to go check in the chat if there are any questions, if nobody is left behind. Okay, I see nothing. I'm assuming everybody is okay. Okay. Let's see. Okay. Everybody is okay. So since everyone is on the same page, can you please print the basic statistic of the mean of the data that we're looking at, and please put your answer in the chat. Anybody? Guys, am I not getting a response because you're stuck and you don't want to say, or because this is easy for you and you've finished everything and we're good? Okay, we have an answer for the mean. Anybody else? Okay, thank you, Sashabo. So, okay, I'm gonna run the mean. And Sashabo and I have different answers. And the reason why we have different answers is because the file that I gave you for the NO2 South Africa _ demo actually included more of South Africa, more of Africa than the one that I have does right now. So the answer is not incorrect. My file is a bit smaller. And you'll see when we are plotting, the data, how my file or the data in my file differs from the data in your file. Still the same data. However, the subset was different, right? And then the standard deviation, we get that. We have the median. So, can somebody please run line 69 and 70? Well, 69 and 70 on my side, to show the latitude, and then put the latitude range and longitude range in the chat, and then I'll show you my longitude and latitude range, and then you'll see how different our data sets are. Thank you, Sashabon. Right. So your latitude range is -40.99 to 4.47, and mine is -39.66 to -21.48. and my longitude is also different to yours, right? So that was just for me to show you that when you are subsetting your data, you should also be careful on the coordinates that you put. And just because the data file is smaller or the data file is subset does not mean you actually understand what's in there, right? Great. So I have a feeling that others are still left behind, even though they're not saying so. So before we map our data, I'm going to suggest that we take a 5-minute break to catch up everybody. And then we can make a map. Is everybody okay with that? No news is good news, I guess. I'll take it like that again. So, so it'll take 5 minutes. And please put your errors in the chat or let us know if you are being assisted in your venue so that we can help catch up everybody to the point that we are at and we can make our maps. Oh. Oh, true story. Thank you. I was in a thread and I couldn't see everybody else's complaints. ASCII scene. Okay, great. So we'll take 5 minutes to try and resolve a few of these little glitches. Right. Okay. Right. Okay, so we have that. Christopher, have you managed to get some assistance? Okay. So the one that says no module name Katopi, you need to install Katopi first. And if you look at the file, oh, it's not here, but you can use pip install Katopi and then try and run the import katopi.crs again. Right. So I'm using Python 3.9. I'm not sure what other people are using, but I think 3.8, 3.9 should be okay. Which version are you on, training? Innocentia, same thing. Please install Katopi first. Thank you. Bonga, the map will be displayed here in our plots. That's where we are going to display the map. Name DS is not defined. You probably, let me see. You did miss the part where we were defining DS, which was here. We defined DS from file name. So you would need to make sure that you run everything so that it doesn't say the name you're calling is not defined. Okay. Let's see. So you just need to install, Christopher, you need to install NITheP also. Yeah. DS invalid. Are you, Samuel, are you using Spider? Okay, okay. Fails to build solvable wheels. Nicholas, have you managed? Or are you still struggling? Okay, we have 3.1.2, 3.1.3. Ah, wonderful, Christopher. You've even gone ahead of all of us. Okay, so those that are having the error that says module not found, please install the module that it says is not found, which is probably NITheP. You can use pip install NITheP, or you can do it in Bash. I don't think you guys have had a demo on how to, well, I'm assuming some of you do know how to install in the terminal. I mean, in using Bash. If you are familiar with that, you can follow the instructions on line 11. Right, the shell command, conda install. Otherwise, you can use pip install. File name. Tim, I am looking at your error. Right, so Chris had the same error as the people that are struggling to install NITheP. And this is what he did. Please check if that is working for you. And so in Essentia, did you pip install in Spider? Because it does happen sometimes that NITheP gives you a problem because of the dependencies. And I think that's why, that's why I gave that warning that you should probably do it on Bash. No, you are not missing. So, Afiz, you should have the code that you got online, and you should have this file, this one. no2_southafrica.demo.nc, and you get that from GitHub. I did put a link in the notes in the Canvas notes. Yes, so in essentially, I do understand. Okay, so yeah, you used pip install, and that is probably why you are getting that error. Yes, in essentially, that is probably why you're getting that error, and that's because of the dependencies, right? Pilontle says he used sudo instead of pip install. And this is what he did. So you can probably try that too. At 2:30, we're going back, right? We're going to plot the data. Is everybody okay with that? And then those that are not able to plot the data, then we can use the rest of the time to look at your errors, or maybe just maybe 30 minutes to look at your errors, then we take a break, and then we can code along to another mapping exercise. Please do let me know in the chat. So I'm going to mute myself and then just answer in the chat. One minute to go. David, have you managed? Mokano, so you have an invalid version of Python. Oh, okay. Interesting. NeoVim. Is that, David, is that a virtual environment? So we got a question. Olua Samuel. Samuel asked, what is the difference between NITCDF4? What is the difference between a NITCDF4 object and NumPy array? So the key differences are in, if I recall, in the structure and metadata, if I recall well. So the NITCDF, which is an X-array dataset, the structure has named dimensions and coordinates, whereas the NumPy array only has shape. And then a NITCDF has metadata, and the NumPy array does not, right? One other thing is the indexing that you use. In a NITCDF or X-array dataset, you can index by using coordinate names, whereas in a NumPy array, you use integer indices only. Yes, integer indices only. So wonderful. More people are catching up. Boucher, thank you for your output, for your basic statistics. Mafokane, unable to open the file. No such file or directory. Have you? Oh, yes. So the file you're trying to open, Makofane, is not there. I didn't give you that file. You should be opening no2_South Africa_demo.nc. Wonderful. Yes. So we are getting the maps in the chat. So I'm assuming some of us are there. So can I move to the mapping, guys? Can I please have, for those that have not mapped, can we map our data? Please give a thumbs up. Palisa, that file is in GitHub. So there's a link on Canvas that will take you to GitHub where you get the file that you need. We haven't, Lefronolo, you're injured. What's wrong? Please tell us your error. Thank you, Courtney. Great. Dibuo, thank you. Okay, somebody says they still need some time. Bongi Kosi. All right, so because some people have already started mapping, I'm gonna map, and then those that are still behind or that are still not on the same page, we will try and catch up. I'll be with you now. Thank you, Sitlavo. I will be with you now. Great. So what we're going to be doing now is we're going to be plotting with Katopi. That is the one that is giving everybody problems. Well, most people problems. So what it does is it's going to create a map figure, as you've seen from the messages in the chat. And it's going to use a plate carry projection, which uses a latitude longitude grid, right? And what we've done here is we have set our extension to, or our map to zoom in on South Africa, right? And to zoom in on South Africa. So yeah, okay, we'll play with this a bit later. And then we have the grid lines that we're using. We are also adding borders. We have coastlines. We have our labels, but we'll see the output, right? So one important thing that I just wanted to mention was the masking, right? The masking. So we are masking missing values and we are setting a minimum of 0. So if it's NaN, if it's negative something, we are setting it to 0, right? And then one thing that we have done, we have adjusted the scale color for better visualization. Right. And then the next part of code. So what this is saying is that the first thing we're going to do is we are going to attempt to plot it as gridded data. Right. And then if that doesn't work, we are going to do it as swath data. Right. And the reason why we do that is because satellite data sometimes they are not perfectly gridded, and therefore when you use gridded, when you plot it as gridded data, you don't get the map that you should get, right? You get an incorrect output. So what I did here was just to give you options. So in case you want to use this code later, you can try the different options that we have. Right. So there. So as you can see, my file, as I mentioned earlier, was reduced even more than the file that I had sent you guys. So what one can do is you can subset the data as small as you want. And in this case, you can see that when we were plotting our data, the extent of South Africa is obviously false because it includes much more than just South Africa, right? So that is what I got. I'm going to go back to the chat. So what I want everybody who's been able to plot their maps, I want you to copy this code below. And then I want you to play around with the extent of South Africa. And then we can see who gets it as close to just South Africa as possible. So play around with that and please send your solutions in the chat. I'm going to mute myself, go back to those that are still behind, and hopefully before we go on our break, we'll all be on the same page. Thank you for helping each other out in the chat. Letshono, you still, how did you install it? Letshono, did you use pip? Unless you found a solution and you don't need me to try help you sort this out. Zamahlase, I see your question. Let's say I would like to clip or extract my data for South Africa or Namibia. How do I do that? So from the big file, right? From that large file that I showed earlier. So I'm just gonna open that script and show you. So now you can use a shapefile. You definitely can. But that's a coding exercise for another day. But yes, you can use a shapefile. And if you use a shapefile, then you definitely know that the borders, the national borders and the municipal borders, if you need those, are only specifically for that area that you are looking at. Yeah. Zama. Line 32 on the code that's on the screen. So if you want to just have South Africa, you would subset using this bounding box. So you see here, I was trying to get as close to South Africa. When you look at the data, don't look at the Katopi boundaries. When you look at the data, I was just trying to get as close to South Africa as I can. So you will put your latitude and your longitude. So if you wanted to do that for Namibia, you would put the coordinates for Namibia. That is when you are now extracting data from the big file, just for Namibia. And then when you're plotting it, also, you will, where is she? There, the extent. When you're setting your extent, so you will be changing these to Namibia. I hope that answers your question, Zamahlase. Thank you, Jason. This looks good. This looks great. Wonderful. Everybody else, have you tried? Linda Gushe is saying, can I use this to create a time series for some years based on indices such as NDVI or series? Yes, to create a time series, you'll need a different code, right? Because here we just did basic stats and we just mapping. So you can definitely do that, but not with this code, not with the specific code. You won't get a time series for this. Yeah. And yeah, you can do that with NDVI or Savvy. At setting our extent, can we include a shapefile? Definitely, you can. You can definitely include a shapefile. Thank you, Mkhululi. So my next challenge is that, sorry, lost my cursor. My next challenge is that when you see, when you're setting your title for your map, please change the title, right? So we have Sentinel NO2 Swath data, 19 May 2025, because it's for that day. Please put an underscore and put your name, so that when you're sending us your picture, when you're sending us your output, we know who it belongs to. Great. Okay. Lemohang. Do we have any other questions while we're trying to catch up the others? Those who don't have questions, you can take a break, or you can play around with the coordinates and just share with us what you get. Right. Awesome. Hi, Shengwe. I was saying, when you are plotting your data, please change the title. Well, amend it. Just put an underscore and then put your name here, so that when you produce the plot, we get your name here. Awesome. Can you try Conda install? Have you tried that? Because what happens is sometimes when we use pip install, it does install. However, it installs in a different folder to where your actual Python is, and then you have clashes. It just can't find it. It's there, but it just can't find it. So for those that have managed to plot and are doing the amendment of the title using name and also cropping the plot, the projection, to as close as you can to South Africa as you can. If you're done with that, you can take an early break and we shall resume at 3:15. Naledi, are you working? Did you try install in Spider or in Bash? Okay. Let's see. So it could be because it says the invalid version. It could be because, let's see. It could be a clash, right? And at the moment, I don't think I want to, the solution I'm thinking of right now is to uninstall and reinstall. And I don't think you want to do that now. And I don't think I want you to do that now. Yeah. I think that's the only solution I can think of now. If anybody can assist Naledi and I to fix the invalid version error that she's getting, she used Bash. If there's any other solution besides uninstalling some of her packages, right? Because we might be here the whole day if we are uninstalling and reinstalling packages. Thank you, Mkululi. Thank you, Arno. Thank you, Boucher. Yeah, everybody has, well, okay, not everybody. Most of us have gotten the hang of this. Thank you, Rose. If you're having, so we have a message says, if you're having trouble with your packages, try navigating to the folder location in Anaconda prompt, then run the conda install command. Close the spider once the install is done and load your .py file again. And this person says it worked for them. And you can also use git bash to do the same. Thank you so much for that. And I think that's much better than uninstalling. Okay. So I'm going to mute myself. And then I will respond in the chat. Otherwise, we'll resume at 15:15. Hi guys, welcome back. No title. Sorry, I just saw a question. Well done, Naledi. Afiz, I'll assist you now. So I hope everybody that finished earlier had a nice break. But okay, what I want to say is for the next part, we are going to be playing around with some of the things that we have here. Right. So I've seen some of your outputs. Some of you have already started playing around with the borders and the colors. Right. So what I want us to do next, we're just concentrating on the mapping for now. I would like for us to change the borders of the map that you made to any other color besides black, right? To any other color besides black. And then change the figure size, right? So change the figure size to whatever figure size you want, right? So whatever you get, just put it in the chat so we can see. And then next, I want us to play around with the color of the map. So with the color of the map, we have viridis. We have, so you can choose viridis, inferno, plasma. I'm gonna remember the others now. For now, I'm just remembering these two. So choose any one of them, right? So the first thing you do is change the border colors. Please only make a map of as close as you can get to South Africa. So change the border colors to something else besides black. Change the color of the map from viridis to inferno or plasma. And now I forgot what I was stressing about. Oh, and then change the size of your figure. Change the size of your figure. Great. So I'm going to give you 5 minutes for that. Should be enough. And then, yeah. So, please. Afiz, it seems like you are plotting, it seems like you only plotted, like you plotted an empty data set, because Katopi will still give you the map outline. It seems like you plotted an empty data set. Would you like to share what you actually were plotting? So you're changing the border colors to something else besides black. Your map, for those that had not done it before, your map is basically as close as it can get to just showing South Africa, right? And then you are increasing the size of your map there. Is everybody still okay? Okay, Belinda. So the instructions are change the size of your map, change the borders to any other color besides black. Yes, so change the size of your figure, change the borders to any other color besides black, and then the color of your map, use infernal or plasma. Anything else besides viridis for anybody, for other people who know the other color maps, because I've forgotten the others. Yeah. Thank you. So for those that have tried using a different, that have put pictures using a different color map. So if you were writing a paper, a manuscript, or you're presenting something, and you had to show this data for this day, right, for your presentation, which color map between these three, or if you used a different one, if you know a different one that I forgot, which of these color maps or CMap would you use and why? Right, because the whole point of us plotting this is to share information with our peers. So please do let me know what you think. Thanks, Belinda. Naledi, you're on a roll. Thank you, Christopher. Thanks, Mpilwendle. Maybe change Mpilwendle, maybe use a different, okay, a different color for the map and not the blue one, which is the Viridis that we just used. So you, Courtney, are you removing the other one? Sorry. So yeah, we would remove that. Maybe that's why it's not working, because yeah, or otherwise. Okay, so I'm getting some answers in there. Hlengiwe would use CVDs and why? Oh, and plasma for presentation. Okay, okay. I hear you. And that's probably because, you know, obviously the output is different depending on which color map you're using and who your audience are. And again, when we are doing presentations, we also need to be very accommodating, right, of the colorblind community. So that also plays a role. Christopher says it creates a sharp contrast, yes, between the NO2 measurements and the borders of the country. So you can easily see, right, the hotspots or the areas with elevated levels than the areas that have much lower levels, right? Thank you, thank you. Okay. Love it. Thank you, guys. Thank you so much. So Hlengiwe says should use Theorities because it shows gradual changes in the data clearly and evenly. And it doesn't overstate high or low values. Yes, that's also true. And again, this also, as Hlengiwe says, it remains readable for colorblind viewers, and it also works well when you printing in grayscale of the shades. Thank you, Cameron. Right. Okay, as the others are still doing the other part that I asked for, the next exercise, this is the last exercise, I promise. The next exercise that I want you to do, this will include you toggling between demo part 2 and observations demo. So the snippet that I put in Canvas, that code, and the code that you got from GitHub. So it will include toggling between those so that you can subset the already subset data. So the data file that I gave you, NO2 South Africa _ demo.nc, your activity or your challenge, your task is to subset that data to Gauteng only, and then create another file, another NetCDF file, right? Called NO2 _ Gauteng _ demo. I will share all that in the chat. So that's the next thing that we will be doing. Is everybody good with that? So I'll give you some clues. So you already have imported your, yes, so you've already imported your X-ray and your NumPy as NP. You don't have to do that again. And you have already called in the file that I'm talking about, NO2 _ South Africa _ demo.nc. And then you have opened that file, right? So the next thing to do to subset that file to Gauteng province only, right? Subset to Gauteng. So we're going to subset to Gauteng province only. So the first thing we're going to do is we're going to have a latitude. You're going to define a smaller bounding box like we had. So this is what I mean by you're going to have to toggle between the codes. And I'm going to the codes. I'm doing this to show you how you can build a different, what's this thing? You can make a new code with the code that you have, right? So you already have this, and you've already opened that. Right, so you copy that, you copy that. And then the next thing that we are going to do, okay, let me make it a bit easy for you. Those that are not looking, might miss out on what's the tips and tricks. So we're going to define a smaller bounding box. So I had already done that. So we're gonna do that. I think it's better if I put in the chat now, then you guys can just follow from there. Right. So you're gonna define a smaller box. And then you are going to subset that data. So you're going to call it ds underscore Gauteng. So you subset your data. So all the codes, I'm putting all this in the chat. So copy it and run it on your script, and then I'll also run it on my side. Right. And then after that, we subset. We save the new data set. So I'm going to leave a few things out so I can see if we've all been following. So we're going to change that. Right. So is everybody following? And the brave ones can plot only the Gauteng data. And please note that what I put in there, the approximate latitude range and longitude range, is just that, approximate. So basically, I've given you the entire code. The only thing that I did not put was when you're saving the new subset data. There's no line there. So you just need to put something there. So you do that. Then remember your drop true. so that you can drop all the points outside of the region. All right. So you don't have to do this, the optional masking of the values, because you have already, you've masked the data before. Thank you, Tammy. Okay. So yeah, so when you save the new subset, giving you the answer already, there, print. So once you've done this, please take a screenshot of your files and show me that you have a dataset underscore Gauteng. Yeah. You have that in your file. And then we'll be done for today. Thank you, thank you. So we have one person who's already managed to do that. And if you're brave enough, you can plot your NO2 Gauteng demo data. You can use this exact code, FMAP. But then you get to decide the extent. So remember, this is not just South Africa. So you've played with this and you've made it South Africa. So basically, you can plot that data again. Awesome. Okay, Samuel, I will share the codes. They are in GitHub. This one that we just did now, I will also put on GitHub. I will put the updated demo script on GitHub. And I'll share the link on Canvas. All right. Thank you, Leolong. Ah, there you go. Thank you, Zamahlase. So basically, this is showing us that you don't always have to work with a big data set, right? You can subset it to as small as you need to, but obviously make sure that you don't lose the important data that you need for your analyses. You can always make sure that the data that you have is projected on the area that you need it to be projected onto, which you can use a shapefile as others have said, or you can use NITheP and just make sure that you are defining the extent of your area properly, right? So thank you very much. So those that are done, wonderful, thank you. See you tomorrow. If you don't want to be brave and plot the map. There we go, Mfundo, thank you. Thank you. Mfundo has plotted the Gauteng data. And obviously it's just a little square inside South Africa. And we also have Bivar who plotted his data. Yeah, I thought I could share that, but that's not the case. It is well. Cool. Thank you. We also have a map from Bivar, and he's just showing the data itself. Right. And what Bivor did is he did not plot it in South Africa, but he plotted just that data for Gauteng. So interesting. Thank you. Thank you, guys. Others you can see, thank you, Isaac. Tomorrow is Saturday, Monday. See you Monday, Charles. Sorry. See you Monday. Thank you, Isaac. Not tomorrow, guys. Do not log in tomorrow, Saturday. Wonderful. Thank you. Thank you. See you Monday, Tendo. Thank you, everybody. I will put the updated script on GitHub. And yeah, if you have any questions, if you want to further look into working with atmospheric or meteorological data, you can reach out to me. I will put my email address somewhere on Canvas or in the chat. Yeah, awesome. Thank you, guys. I'll wait for the others that are still doing this activity. Thank you.
Okay, cheers.
Thank you so much.
Thank you, Rafil. Just got a little message for you there. Can you just kindly try and put your files basically on Canvas so that we can have access to them. The links are currently blocked.
Tim Sanga, should I paste this code for subsetting to Gauteng in announcements? Is that what you want?
No. Basically, I think they are files that you shared with Benjamin. You can just maybe, because I think they are blocked, the links that you sent to Benjamin are currently blocked. You can just paste those files on Canvas. I can have a chat with Benjamin on via email or on Slack and find out which files is he speaking about.
I will ask admin to post it in announcements.
Okay.
Otherwise, you'll find it on GitHub.
Okay.
Awesome.
No problem. Thank you very much for an engaging session as well. That was very fruitful. Thank you very much for that.
There's no quiz for this, Christopher. This is just vibes. This is fun. Bivar, I will send the presentation too. No problem. Thank you, Belinda. Also enjoyed it. Yes, no quiz, guys. No quiz. It was a fun demo for everybody. Thank you, Shengyue. So if there are no other announcements from Benjamin and other staff, I think everybody, if you're done with the activity, you may go. Thank you. See you Monday.
Okay, so Rafil, just a quick one to remind the guys about Monday as well. The time we're starting on Monday, we start the same time for the second week as well. We start around 9:30, same time. So we'll be doing computation thinking as from Monday. So yeah, just to note that as well. So yeah, other than that, have a great weekend, guys. Thank you.
Thank you, Sandile. That looks very cool. there's an announcement to remind you to submit your Streamlit app by Monday midday. Don't forget that.